Hello again. In the previous videos, we have created a data science pipeline that allows us to train our model, and we have managed to run the same version of the pipeline with two different sets of inputs. So this is a really powerful way of trying out the same pipeline, but in different ways. Now, let's see a couple more interesting things before we close this section. First of all, the previous part, which was the data processing part, already stays the same. And then after the model input table, there's two pipelines now, active modeling pipeline and the candidate modeling pipeline. Now, the interesting thing is that since they are namespace pipelines, I can open any of them, and I'm going to see how different things are happening inside it. If you see the menu on the left, you see that this expansion also happened on here. So if I collapse that again, I'm back to the previous view, and I can do the same with this pipeline or even expand both at the same time so I can see all the pipeline in its full glory. Now, if you think about this a little bit, you can imagine that there's lots of things happening that could be happening at the same time. This is not probably going to be the case now because our datasets are quite small, but if our pipeline gets really big, we have to increase the performance of Kedro somehow. So we're going to see how to do that. Remember that previously, when we were running our Kedro pipeline, by doing Kedro run pipeline data science, even if it's difficult to see because things are going really fast, everything is happening sequentially. The reason for this is that by default, Kedro uses a sequential runner that runs all the nodes one after another, still in the correct order, but sequentially. Now, what can we do to change that? There's another set of runners called the thread runners, for example, and I can specify the data science pipeline again. So instead of running things sequentially, this is going to make use of Python threads so that things are a little bit faster. Additionally, there's one more runner. We use Kedro run, runner, parallel runner, and I specify again my pipeline, data science. And similarly, this is also going to be quite fast. Now, whether you should use the thread runner or the parallel runner depends a lot on your code. For example, if your code has a lot of I/O and is not CPU bound, so it's I/O bound, then you probably should be using the thread runner because then you can leverage the power of your computer much more effectively. On the other hand, if your pipeline is CPU bound, which is probably going to be the case, you should be using the parallel runner instead. That is going to use multiprocessing, and therefore different Python processes can use the CPU at the same time. Thanks to this, your pipelines are going to run much quicker, and if you have a very big project, this is going to be a real advantage. And there is one last thing that was introduced recently in Kedro that I want to talk to you about. So if you remember from our catalog, you see that we have our active modeling pipeline regressor and the candidate modeling pipeline regressor. But if you want to try lots of different combinations of input parameters, this might get really tedious if you have to copy-paste this definition over and over again. Luckily, in recent versions of Kedro, there's a really interesting way of making this easier thanks to the use of dataset factories. So that was it for a review on how you can use KedroViz to explore namespace pipelines, and also how can you use the different runners to accelerate the performance of your code. In the next video, we're going to close this section by showing one of the most interesting features that have been introduced in Kedro in recent releases, which is dataset factories. See you in the next video.